Hi viewers, welcome to my channel. In the today's class, now I am going to present the topic, the derivation of the Kepler's first law. So first, let us see the statements. The planets revolve around the sun in an elliptical orbit. This is the Kepler's first law. It is also known as the law of orbit. Okay. Now, in this class, we have to prove the Kepler's first law. That is, we have to show the path followed by the planet is an ellipse. So for that, let us consider this, right? Okay. Yeah. So consider a planet of mass smaller is moving around the sun, okay, around the sun of mass capital M in an orbit. We don't know what is that. So that orbit we have to show the ellipse. According to Newton's gravitational law, according to Newton's gravitational law, the gravitational attraction force between Sun and Earth is given by F is equal to minus GMM by R square into R cap. Okay. R cap is the unit vector along the direction of R bar, where negative sign indicates the force is attractive force. But we have the force F bar is equal to central force, F bar equal to F of R into R cap. So comparing this, it's very clear. The magnitude of the force F of R equal to GMM by R square. Okay. The equation 2. So from this, force per unit mass is given by equal to F of R by small m. Force per unit mass for the planet acting on the planet equal to G capital M by R square. That equal I am writing mu by R square, where I have taken the substitution mu is equal to capital G capital M. Of course, capital G is Newton's gravitational constant, M mass of the sun. Okay. Now, so here the gravitational attraction force accepted by the sun on the planet is the central force. Therefore, for this, the existing gravitational attraction force between sun and earth is, since it is the central force, the differential equation of motion, for central force is given by, okay, central force is given by, already we proved in the previous class, what is that? D square u by d theta square plus u is equal to p by h square u square. Okay. P P by h square u square. That equals to mu by r square by h square u square. Okay, mu by r square by h square u square equal to mu by h square. Say this is equation 4. Because there we have taken the substitution, force per unit mass P is equal to F of R by small m. That equal to mu by R square substituted. This is one thing. And also R is equal to the reciprocal of U, or U equal to 1 by R. So there R square is equal to 1 by U square substituted. Hence U square is square cancelled. Then what left? D square U by D theta square plus U is equal to mu by H square. This is the equation 4. That's it. Of course, here already I told you that H is a constant, that is angular momentum per unit mass. U is equal to the reciprocal of radius vector, right? The solution of equation 4. Equation 4 is the second order differential equation. Its solution has the form U is equal to mu by H square plus A cos of theta minus theta naught. Equation 5. Where A and A constant, H constant, and theta naught is also constant. But we have U is equal to what? That's the reciprocal of radius vector. 1 by R equals to mu by H square plus A cos of theta minus theta. 1 by R equals to right side, you take the common mu by H square. By taking that common, 1 plus A cos of theta minus theta naught by mu by H square. Okay, so then we can write 1 plus, here H square goes to the numerator, then what we get, A H square by mu cos of theta minus theta naught whole by H square by mu. Okay, say this is equation sum 5b. So let us compare this equation with the equation of conic section. So comparing this equation with the conic section equation. Conic section general equation to compare this equation. Then what can we write? What is the conic section equation? 1 by R is equals to 1 plus epsilon cos theta by L. Equation 6. Equation 5 and 6 compare this. It's very clear. L is equals to H square by mu. This is called semi-lattice rectum. Semi-lattice rectum. Okay. And epsilon is equals to A H square by mu. This is called eccentricity. Eccentricity of the conic section. Right. So our intention is we have to prove the path followed by the planet is ellipse. Because Kepler's first law, what it states, planets revolve around the sun in an elliptical orbit. Right. So for that, our approach is, first we have to calculate kinetic energy of the planet. Next, potential energy of the planet. Then we calculate the total energy by doing the sum of kinetic energy and potential energy. right? Finally, then if you prove the eccentricity is less than 1, then it is very clear that the orbit is ellipse. This is the approach. Okay, when eccentricity epsilon less than 1, the orbit is ellipse. Epsilon is equals to 1. What is the shape of the orbit? When epsilon equals to 1, parabola, right? When epsilon greater than 1, that is hyperbola. Hyperbola. So here we have to show epsilon less than 1. For that, our approach is first we calculate kinetic energy, next potential energy, then total energy. Next, by doing some simplification, finally we will prove epsilon less than 1. Therefore, the orbit followed by the planet around the sun is ellipse. Right. For that, let us see kinetic energy of the planet. Kinetic energy of the planet Ke is equal to, I'm showing with the capital T, that equal of mv square, that equal of m, right? Here v square is equal to dr by dt whole square plus r square and d theta by dt whole square. You should remember this. Okay, uh, velocity magnitude v equal to root of dr by dt whole square plus r square d theta by dt whole square. Hence v square equal to dr by dt whole square plus r square d theta by dt whole square. So ఇది v square అన్నమాట. ఈ స్క్వేర్ బ్రాకెట్ లో ఉంది. దీన్ని equation, okay, no problem. So from this, but what we have the substitution dr by dt is equals to minus h du by d theta, and d theta by dt is equals to, you should remember this, h u square. Next, r is equal to 1 by u. All this we used in the derivation of the equation of motion of the particle moving under the central force. From that, I have taken direct substitution. dr by dt equal minus h du by d theta, d theta by dt equal to h u square, r is equal to 1 by u. Okay. ఈ వాల్యూస్ మనం పై ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేస్తే kinetic energy equal to half m dr by dt whole square h square du by d theta whole square plus r square is 1 by u square d theta by dt whole square h square u power 4, that equal to half m h square కూడా కామన్ తీస్తే then du by d theta whole square plus u square cancel. So what left? What left? Um, d theta by dt equal to h u square. H square u power 4. Okay. Then h square కూడా మనం కామన్ తీసాం. Right. H square u power 4. Okay. So this is h square u square. Then d theta by dt whole square, what with h power 4, h power 4, u power 4. H square common తీస్తే h square u square ఉంటుంది. Okay. H square u square. Right. Kinetic energy equal to half mv square, half m into dr by dt whole square plus r square d theta by dt whole square. Dr by dt equal to minus h du by d theta, right? D theta by dt is equal to h u square, h u square. D theta by dt equal to h u square. Okay, right. Dr by dt equal to minus h du by d theta, right. Dr by dt whole square, h square du by d theta whole square plus, right. then of m h square that plus mu square by h power 4 more correction with this one or 1 by u square d theta by dt whole square, and there we get h square. So here h square already taking common this one, right? Now this is the correct. And yes, dr by dt equal to minus h du by d theta by dt equal to h u square r equal to 1 by u. ఈ వాల్యూస్ పై ఈక్వేషన్ లో దీంట్లో సబ్స్టిట్యూట్ చేశాం. హాఫ్ m dr by dt whole square h square du by d theta whole square plus, but r equal 1 by u, there we have r square 1 by u square d theta by dt whole square h square u power 4. Then by h square taking common of m h square du by d theta whole square plus u square. Okay, now but what we have, u is equal to the solution of the equation of motion for the central force, u equal to mu by h square plus e cos of theta minus theta naught. From this, d square u by d theta square you can write, that equal a square sine square theta minus theta naught. U square is equal to mu by h square plus e cos of theta minus theta naught whole square. ఈ వాల్యూస్ ని ఇంతకుముందు వచ్చినటువంటి ప్రీవియస్ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేస్తే మనకి ఏమొస్తుంది, kinetic energy of the planet equation లో సబ్స్టిట్యూట్ చేస్తే హాఫ్ mh square into that is d square u by d theta square a square sine square theta minus theta naught plus u square. So this is whole square mu by h square plus a cos of theta minus theta naught whole square equal to half mh square into a square sine square theta minus theta naught. It is in the form a plus b whole square. Expand that mu square by h power 4 plus a square cos square theta minus theta naught plus 2a by h square cos of theta minus theta naught. From these two terms, by taking a square common, sine square of theta minus theta naught plus cos square of theta minus theta naught 1. Okay, then kinetic energy of the planet equal to half mh square into bracket low a square plus mu square by h power 4 plus 2 mu a by h square cos of theta minus theta naught into then equation 7. Okay, now potential energy of the planet equals to integral r to infinity f bar dot dr bar, that equal to minus integral r to infinity f bar dot dr bar, that value gmm by r square dr, where f bar and the dr bar direction in opposite, so that f bar dot dr bar minus f dr. F is equal to gravitational force of attraction between sun and earth, that is g capital M small m by r square dr. This is equal to minus integral r to infinity, but gm is equal to, we have taken the substitution what, mu m by r square dr, where mu is constant, m is constant, minus mu m 1 by r square integration minus 1 by r. Okay, limits r to infinity. Minus into minus gets plus mu m by r limits r to infinity. That equal to first substitute upper limit mu m by infinity minus mu m by r. First term becomes 0. This is equal to minus mu m r is equal to 1 by r equal to u. Therefore, potential energy is equal to minus mu m, but u equal to, we have mu by h square plus a cos of theta minus theta naught. This is equation 8. So we derived the expression for kinetic energy of the planet and the potential energy of the planet. Next, let us do the total energy. Now the total energy of the planet E is equal to, I'm denoting with capital E, that equal sum of kinetic energy and potential energy. Then E is equal kinetic energy, what we get of mh square, A square plus mu square by h power 4 plus 2 mu A by h square cos of theta minus theta naught plus potential energy expression, we got minus mu m into mu by h square plus a cos of theta minus theta naught, right? In these two terms, let us take the common of mh square. Then, in the first term, write the uh, terms, the square bracket as it is, a square plus mu square by h power 4 plus 2 mu a by h square cos of theta minus theta naught. Next, minus here 2 minus mu square m mu square m by h square mu square m by h square. So that is already we done. Okay. So by taking off mh square common in the second big term, here we get the terms minus 2 mu square by h power 4 minus 2 mu a by h square cos of theta minus theta naught. So these two terms cancel. Then capital E is equal to of mh square into a square plus mu square by h power 4 mu square by h power 4 minus 2 mu square by h power 4. Okay. Then capital E is equal to of mh square into a square minus mu square by h power 4. Okay. So from this, by taking cross multiplication, 2e by mh square is equal to right side a square minus mu square by h power 4. From that, you write a square as the subject, 2e by mh square plus mu square by h power 4. Okay, that equals to, there you take the common mu square by h power 4, then 1 plus 2e h square by m mu square. Therefore, A is equal to, taking square root both sides, mu by h square into 1 plus 2e h square by m mu square whole power of. Okay, this is equation 9. But we have, but what we have semi-lattice rectum L is equal to h square by mu, that equal to b square by a. And eccentricity E is equal to a h square by mu. Okay. From equation 9, we can write a h square by mu is equals to, from equation 9, we can write 1 plus 2e h square by m mu square whole power of. So this is the expression for eccentricity of the conic section. Right. E is equal to 1 plus 2e h square by mu m mu square, mu equal to capital G capital M, substituting that capital G square capital M square whole power of. Right. So in this, we know from the properties of the conic section, what we know, so that is I'm writing from the properties of conic section. If eccentricity less than 1, then orbit is ellipse. If eccentricity is equal to 1, then conic section is a parabola. If eccentricity greater than 1, then conic section is said to be hyperbola. This is final. But from above expression, what is that expression? Eccentricity E is equal to 1 plus 2e h square by small m g square m square whole power of. ఈ ఎక్స్ప్రెషన్లో మనకు ఇక్కడ 3 కేసెస్ చెప్తున్నాను. ఇఫ్ క్యాపిటల్ ఈ లెస్ దాన్ 0 అయినంత, then epsilon less than 1 అవుతుంది. Second case, if the total energy of the planet E equals to 0 అయితే, then E is equal to 1 అవుతుంది. Third case, the total energy of the planet greater than 0 positive అయితే, then eccentricity greater than 1 అవుతుంది. Right? So this is the main equation. మనకు లాస్ట్ వచ్చినటువంటి ఎక్స్ప్రెషన్ మనకు మన ప్రాబ్లం సంబంధించి, సో దట్ ఈస్ వాట్ అవర్ ప్లానటరీ సిస్టమ్. యాజ్ ఫర్ యాజ్ అవర్ ప్రాబ్లమ్ ఇస్ కన్సర్న్, that is for planetary system, it is a bounded system. Okay. So since it is a bounded system, because planet revolving around the sun subjected to the attractive force, therefore it is a bounded system. If it is a bounded system, then total energy must be less than 0, negative, right? If it is negative, obviously eccentricity less than 1. Therefore, the orbit must be ellipse. The orbit must be ellipse. Hence, the path of the orbit is the ellipse. Therefore, the planet revolving around the sun in an elliptical orbit. Hence, Kepler's first law is proved. Okay.